Much like Friday, today, the expectation here is that you continue to work on your biasing circuitry and all that kind of jazz. Hopefully completing effectively the right-hand side of the circuit, which is two wide swing current mirrors, one using PMOSs, which is this guy over here on the left, and then another using NMOSs, which is this guy over here on the right, to generate all of the different bias voltages that we will be using for the remainder of our circuit. Once you have this done, see you later. If you have questions, feel free to yell at me. I'll be over here grading papers. I'm going to go stand.
Yeah, I would offer my like if you go over all that, probably use that exact example.
Yeah, I will be definitely using that. I gotta just figure out where the heck I am on this circuit.
Yeah, I know. I'm like looking at it, I'm like, my numbers don't really match up.
Got some things up that's off.
Well, also notice he's using 120 by 2 for his PMOS instead of 2.
I know, so my circuit looks a little different.
Yeah. Grace, I'm not sure, but I believe your group might have gotten the highest grade I've ever given on the first round.
Yeah, I don't know why.
Don't tell me who actually wrote it. But it was very well done.
I think it was still like the constraints where we didn't have everything fully thought out. We just had the outline or something. So
I don't think you guys, I haven't given you my feedback yet. So I don't know what Sandra told you. But I actually told Sandra she didn't have to grade them, so I'm not sure why she was doing it, but hey, whatever.
But she told us she was gonna go through and get us some feedback on it. And I think you're clicking stuff. Is your mouse on this one?
Possibly, yep. Let's turn that off.
Okay, so here.
Yeah.
Did we determine what the voltage should be? So let me.
Simulate it. Requires me to turn my mouse on. So this is what I got using 20x2s, not two 10x2s in parallel for the PMOSs, so things could be slightly different.
It shouldn't be drastic.
Shouldn't be drastically different, no. So here's 1, 2, 3.
Is there like a preference to do them one at a time rather than all at the same time? So that to ensure they use like the same scale.
I wasn't sure if I clicked on like several at the same time if it would do it. So that's just me.
That's how.
All right, high, low.
So on those labeled
Okay, yeah.
points on your circuit, the V bias one, V high, V low, are you click on those, pressing Control E to export that?
So let me go back to this. So these guys right here, this arrow type thing is this, so I'm making a off-page thing. Let me just drop it here. I mirrored it the other way and then exported those. So this is what should allow me to effectively connect this to
Other things.
external stages, yeah. So that I can work on this on a stage by stage basis. So what I'm going to attempt to do here, let's see how well this tracks.
Yeah, that was what I was doing. I just labeled the off page instead of exporting. That's what I was showing.
Bring this over here. You can't see everything. And I'm gonna move this. Well, nope, I want this whole thing. So this is the problem with this crap. So that potentially now you can see what it looks like and what the values are ish at the same time. Is that reasonable? You're shaking your head as if something. How significantly different? So I ran into an issue where a lot of mine were zeros, and that means that everything was turned off. So I had to go troubleshooting things.
So take VDD out of there because of course that's 5 volts. That's just a waste of time.
So my V low is quite low.
But that's the point.
Yeah, yeah, it's just.
And we're not gonna use it for anything.
There you go.
So V bias 3 is at a little over 1. V bias 4.
A little under 2.
Right, so now I have to go back. I can't see what. Damn it. Okay, I need,
There's no great way of doing this, is there?
nope. So for me, so my 4 is lower than 3, which is what I would expect. 1 should be at the highest for my bias voltage, then 2, then 3, and then 4. You have them swapped around.
Yeah, 3 and 4. 4 is higher than 3.
Right, which is problematic.
3 and 4, because it's labeled correctly.
Yeah. All right, so where is the handout?
Actually,
So let's start clicking on nodes and seeing where are we. Yeah. Okay. So that seems for V bias 1. So connected to these gates, which is reasonable, connected down here, which is to the.
yeah.
Right. So effectively, we're just looking at these two. That's what that is. And then you have. All right, so that one seems pretty good. So V high should literally just be that thing right there, okay? Is gates from your wide swing all the way over, and then it is tied there, so that seems correct. This is one, two, okay, and then NCAS. So that's that is okay. BCAS. That seems reasonable-ish. 3. So you have, so that bit right there is, okay. So you have a gate connection here. This should be jumping over that gate, and then the gate of what you have right there. Hold on. No, I'm trying to think. So that's right here. Okay, so effectively, the drain of this transistor is supposed to be tied to the gate of this transistor down here, which is true, but it's not supposed to also be connected to V bias 3.
Okay, so
So this point should be connected to this point, but V bias 3 shouldn't also be connected there.
device 3.
So V bias 3 should go from here out to this thing. So delete that, delete this, yeah. And then delete this thing around the outside as well. Delete all that. Okay. So start by tying M in ref 7. Excuse me, actually start by tying this drain out somewhere in the middle, then down to the gate here. All right. And then the gate here, then tie it to there. Yeah.
So
Now rerun your simulation. Yeah. Close it out and rerun the simulation, or whatever. But if you had LT Spice minimized the last time you did it, that's why it opens up like that, and it's done.
Deload 0 plus 3 deload
Around 1.1, where's 4?
4 is
Is that way high up at 3.6?
3.6.
Why is it so close to? All right,
Alright.
so looks like there's something going, so you can open that back all the way and then close it out, or it'll open up that tiny window again. Okay. So now let's look at what's going on with 4. So that, I think
We got
that's
3 sorted out.
So it's tied to the gate of this guy, which is what it looks like. It's tied to the gate of this guy, it's tied to the gate of that guy, and then it is tied to the gate of that guy.
It's also tied to your
Up there, yeah. Okay,
Alright,
so
so
look at low.
low.
Yep. Now let's look at 4. Yes, but it seems reasonable. Why did 4 get so high unless some of your transistors are accidentally off?
Make sure I'm right. Things. This worked.
So re-simulate, and now let's look at the current through some of these transistors and see if some of them are off. So go to ID, and we're looking for the MN wide swings.
M was 1, 2.
3, 4, 5.
Okay, about 6s, 7s, 3s.
All that crap's in series. So
Yeah.
all this is reasonable. It's all somewhere in the ballpark of 20. why the hell is V bias 4 so high?
The wide swing 4 is lower,
But it's not,
but it's not, I mean,
it's 21 instead of 24, which is not 0. Like with that V bias 4 being at such a high potential, right, I was expecting these to look like small resistances, which would pull this point up. Because so V bias 4 should be really small, because this is just between this node and ground.
our wide swing 5 is. No, it's 10
Okay.
That's a 10 by 10 now. So that's 5.
Yeah, when I do it, I'm always seeing the default node names instead of the.
All right, so 4 is below 3, much larger. All right.
Much happier with that.
Yeah, so the reason why is click on that, the adaptation, click on, press Control E. Yeah, instead of doing that, you do Control V to wait.
It's an export though.
Yeah. I did the exact same thing.
CAS and PCAS, yeah. So. Sure, so just 20-ish, which is
Yeah.
to be expected with channel length modulation.
Yeah. So which ones? We check the current one.
If your voltages are looking right, the current's fine. Like. Yeah,
Well, I guess one can happen.
Yeah, like-
Like.
so like when I was looking at things, I was having like a couple of them right, and then a bunch of them either at 0 or VDD, and that's what told me transistors are off. So if they're all stair stepping down from, 5 volts for VDD, and then a VTH, and then a VTH, and then a VTH, all the way trailing down, you got a pretty spot on. Yeah.
I'm not sure mine's quite lining up as it should. Maybe I'm
bias 4,
B bias 4 is this teal colored,
which is way higher than it's supposed to be.
yeah, it's right up here.
So there's gotta be an improper connection.
Okay,
So, what size is that transistor?
10 by 2.
Make it 10 by 10.
Oh, okay, I was just
Because
copying.
that's the
it.
widest wavelength.
Yeah, I was just
Exactly
copying
right.
and I missed that.
That's exactly what happened to Sam a moment ago when we got this connection sorted out. With that as a 10 by 2, it pulled V bias 4 way up. But with it a 10 by 10.
Yeah, now it's saying it's around 1.1.
Yep, so around 1.1 or 1.0-ish seems reasonable, because it should be about 1 threshold voltage plus 1 VD sat, which for this should be ballpark 250 millivolts. So somewhere close to 1 volt is reasonable. Let me just. Again, mine are going to be ever so slightly different because I did not go through and make all my 20 by 2s, 2 10 by 2s in parallel. Yeah, so if I click on V bias 4, I'm getting right at 1.1 volts.
you mind just kind of clicking through the rest of the way you did it that one? Because that's a really easy way. It's kind of hard for me on my eyes to make out.
Wait, do what?
To just kind of see how the rest of my numbers match yours. Because my V-Buy-4 is matching yours almost dead on.
So I click on 3.7 volts,
Yeah, 3.66.
2 is 3 volts,
Yep,
3 is 1.7 volts,
1.67.
4 is 1.1,
Mhm.
high is 4.4, low is half a volt,
Yep.
NCAS is 2.4,
Mhm.
PCAS is 2.2.
2.15, but
Yeah, so everything you've got is pretty reasonable.
Okay. I'm amazed that the problem was that I did a 10x2, not a 10x10, given all the connections in here.
Yeah, so if that wide swing current mirror isn't made at least the length isn't 4 times as long as the other ones in there, it doesn't pull that output voltage down to its minimum possible value. That output voltage is the reference thing that we're using in subsequent stages. So. All right, so seems like most of you guys have got it. So on, yeah, I'm gonna stick around here, but for Wednesday, we're gonna talk about the differential pair / single stage op amp. We're not gonna go through the headache of actually looking at differential pairs with a differential output because we know we're not gonna use it. So we covered that in 335 and, well, no, we covered that in 336 and all that kind of jazz. So. That'll be it. Mhm. Yep, you got the voltages outputting correctly, you're done.